All right. So what are these symbols? This first one is alpha. And this second symbol is beta. And these are Greek letters. And they are actually the first two letters in the Greek alphabet, which is where we actually get the word alpha, bet. Alpha, beta turns into alphabet. We use these Greek letters to name angles. If you don't like them and you want to come in here and put a capital A wherever you see an alpha and a capital B wherever you see a beta, that is okay to do, right? But you should at least look at them and not freak out. They are just Greek letters. All right, for our work today, we are going to need to work with the denominator of 12 a lot. And so we want to go through all the 12ths and just review how to simplify and what we know about them. So I'm just going to come write them down. You write them with me. 1/12, 2/12, 3/12, 4/12, then make a new column. 5/12, 6/12, 7/12, 8/12, then we have 9/12, 10/12, 11/12, and 12/12. So what we want to do is we want to simplify all the ones that we can, and then we want to decide which one of these are fractional parts of our unit circle. So can you simplify 1/12? No. Is 1/12 one of our memory angles on the unit circle? No. So I'm going to put an X next to 1/12. It is not going to help us. What about 2/12? Can you simplify that? Simplifies to 1/6. If you're not that good at simplifying, remember you divide the numerator and the denominator by the greatest common factor. So is pi over 6 on our unit circle? Yes, so I'm going to put a smiley face. You can put a check mark or some other notation. That's going to be helpful to us. All right, 3/12, what does that simplify to be? 1/4. Greatest common factor is 3. Is pi over 4 on your unit circle? Yes. So 3/12 is going to be a helpful fraction for us. 4/12 simplifies to be 1/3 because 4 and 12 are both divisible by 4. Is pi over 3 on the unit circle? Yes, it is. All right, 5/12, can we simplify? No. Is 5/12 on the unit circle? No, it's not. All right, what about 6/12? That's a half. Do we have pi over 2 on our unit circle? Absolutely. 7/12, does it simplify? Is it on the unit circle? No. 8/12 simplifies to be 2/3. 8 and 12 are both divisible by 4. 2 pi over 3 on your unit circle? Yes. All right, 9/12 simplifies to 3/4. 9 and 12 both divisible by 3. Is 3 pi over 4 in the unit circle? Yes. 10 and 12, even numbers, always divisible by 2. 5, 6, 5 pi over 6, yes, is on the unit circle. 11 pi over 12, can you simplify? No. Is it on the unit circle? No. X that out. What does 12/12 simplify to be? 1 whole. Do we have 1 whole pi on the unit circle? Yes, so that's going to be helpful. All right. So if you're really good at simplifying fractions, you need to thank maybe your, I don't know, 3rd or 4th grade teacher for that, because we're going to be using simplifying fractions in part of today's lesson. So we're going to start with example 1. That is going to say, find the exact value for the cosine of 17 pi over 12. All right, so first I want you to grab a calculator. 17 pi over 12, is that in degrees or radians? That's in radians, so make sure your calculator says radians. And then go ahead and press cosine 17 pi divided by 12. All right. So did we get an answer on the calculator? Sure. Is that the exact value? It's not. This decimal doesn't even end. That's just the end of the calculator screen. This decimal is going to keep on going. And if I round the decimal, will I have an exact answer anymore? No. So whenever things ask for an exact value, you don't want a decimal answer. So if right now this calculator is no good, gently toss it to the side. Okay. So instead, we are going to use a trig identity. And here's the way this works. We bring down our cosine, and we make a big parentheses, and we think. We have to use our IB learner profile of being a thinker. And what we want to think about is this. What 2 fractions can add up to 7 pi over 12 where both of those fractions are actually on the unit circle? So you look at your list up here. The first thing I think of is 10 plus 7 is 17. But do I want to use a 7 over 12? No, it's not on the unit circle. So that's not going to be a good combination. So let's try again. What can add up to 17 that is on the unit circle? 8 and 9, all right? Or 9 and 8, but let's put them in numerical order. So we're going to write down 8 pi over 12 and 9 pi over 12. Next step, we're going to simplify. And we just did this, so that should be pretty easy. 8 pi over 12 would be 2 pi over 3. And 9 pi over 12 is going to be 3 pi over 4. Next step, we're going to look at our yellow chart for an identity that has the cosine of 2 different angles being added together. So try and find that on your yellow sheet. When you find it, put your finger on it. Help the people at your table that can't find it. And hopefully you are all looking right here. Cosine alpha plus beta, right? So all I'm going to do is substitute into the right-hand side of this identity. So I'm going to move this off to the side, but I'm going to keep it next to me. I'm actually going to put my left finger right on it while I write with my right hand. 2 pi over 3 is my angle alpha, and 3 pi over 4 is my angle beta. And so I'm going to substitute into the formula. Cosine of alpha, 2 pi over 3, times cosine of beta, which is 3 pi over 4, subtract sine of alpha, which is 2 pi over 3, times sine of beta, which is 3 pi over 4. Okay? Just doing substitution. Now, at this point, I want to evaluate those cosines and sines using what I know about the unit circle. You can flip your yellow chart on the back if necessary, or you may hopefully have these memorized, but in case you don't trust your memory, what is the cosine of 2 pi over 3? Not 3 pi over 2, 2 pi over 3. Find 2 pi over 3. Cosine is negative 1/2. Make sure we're all looking at the right place here. Cosine 2 pi over 3. Remember, in your ordered pairs, x is your cosine, y is your sine. So cosine is negative 1/2. Okay. All right, cosine of 3 pi over 4, negative square root of 2 over 2, minus sine of 2 pi over 3, square root of 3 over 2, sine of 3 pi over 4, square root of 2 over 2. Be careful about positives and negatives when you do this work. And now we're going to do math. We're going to do arithmetic, actually. Order of operations, please excuse my dear Aunt Sally, or PEMDAS says multiply before you subtract. So I multiply these two fractions together, and I get positive square root of 2 over 4. When I multiply these other two fractions, when you multiply radicals, you multiply what's underneath the radical, so I get square root of 6 over 4. And then I go ahead and subtract, and when I have a common denominator, I bring it down, and I just subtract the numerators, and I can't do anything to simplify them, so I just leave them like that. And then we can check on the calculator. So remember, just a minute ago, we typed in and got a decimal answer. So now let's type in this. Now notice all of this square root 2 minus square root of 6 is in the numerator. Remember, this fraction bar is also a grouping symbol. So when I go to put it in the calculator, I have to put parentheses, square root of 2, arrow out of your square root, minus square root of 6, arrow off your square root, close your parentheses, divided by 4. Oh, but I did not even put cosine in the front. So let me insert a cosine. No, Ms. Collier, what are you doing? I don't need a cosine. I was right the first time. I'm just typing this in. So sorry, everyone. Square root of 2, arrow, minus square root of 6, arrow, close parentheses, divided by 4, and just hit enter. And there we go. So we've checked our work.
Good one.